Hello, my name is Antonio, and together with Greg, we are going to show you how we hacked Mario Kart Tour, the Android game. One second. Yeah. So, first of all, we have to ask ourselves the why question. Why hack video games? Well, money, of course. The video game hacking market is a growing market, which has gone up to about $70 million from selling exploits, in a world where Nintendo makes about $15.3 billion only from selling video games. So we can't really say that Nintendo has to be threatened about this, but they still have the responsibility to try and stop the hackers from ruining everyone's game. So, when it comes to video games, what exactly is there worth protecting? As we already know from the tenets of cybersecurity, we have the CIA triad: confidentiality, integrity, and availability, where confidentiality stands for protecting the user's data. Integrity refers to having the video game controls perform the same for everyone, and the availability, well, for the game to be available. What happens if two of these properties, for a video game, excuse me. So for a video game, we are only interested in integrity and availability, since confidentiality is not really a problem when we don't store other users' data on each device. So what happens if we fail to ensure the integrity and the availability of a game? Well, gamers will throw away that game. So game hacking and security have a lot of overlapping, since for each of them we have to reverse engineer, and we can either do a static or dynamic analysis and a forensic analysis to find out the behavior of the game. And for the actual hacking, we have to hook or patch the behavior during runtime. This brings us to the research questions that this presentation is based on, since this was a university project. We also have an accompanying paper. So the questions are: what are the anti-tamper mechanisms implemented in the application, and how can we bypass them? And what are the anti-cheat methods implemented within the application, and of course, how we can bypass them? First, we need to establish the difference between the anti-tamper mechanisms and the anti-cheating mechanisms. Anti-tamper refers to techniques employed to frustrate the efforts of individuals intending to modify the application in a manner not intended by the developers, while anti-cheat refers to techniques used to identify illegitimate gameplay, as well as the means with which we ensure the fairness during the gameplay. To make a quick side note, the anti-tampering techniques are also interesting because they are used in malware applications. Finally, before we get to the part that everyone is waiting for, we have to have a little look at the anatomy of a Unity game. First of all, we need an engine, which in our case is Unity, and the IL2CPP component that takes the C# assembly code that was generated during the creation with the Unity engine, and transform that into C++ code, which then, with the help of the libIL2CPP, can be compiled for multiple platforms, ensuring the portability. Okay, this brings us to the anti-tampering bypasses that we managed to find. First of all, the Mario Kart Tour game was protected by having a metadata file embedded in the binary, whereas normally this metadata file would come in as a separate file. We have the emulator detection, the root detection, and the feature that prevents the game from being played on a rooted phone. The last three features are implemented via safety net attestation, which is Google's library designed specifically to help Android applications for this purpose, and which was later renamed to Play Integrity API. And also we found remnants in the code of the application from Sakasho Safety Net, which seems to be custom code for the same purpose. So during our analysis, we managed to bypass the three bullet points, as you can see: the emulator detection by using an actual phone instead of an emulator, the root detection by using the safety net fix as part of the Magisk module. And with this fix, we were also able to play on the rooted phone. And for the first thing, as I mentioned, it usually comes in a separate file. So in order to actually get access to the metadata file, we had to dump it during the runtime using another Magisk module called Zygisk, or IL2CPP dumper, which dumps all the classes, methods, functions, and their offsets in the binary. Now we can go on to the anti-cheat bypass. For this purpose, we used Frida, which is a well-known dynamic instrumentation toolkit, which injects a JavaScript engine into the running process and basically allows you to hook any function and modify the behavior during runtime. It can also act as a debugger, so you can also see more information live as it happens. We also have a special note here for the author of Frida, which you can give a follow on Twitter. So, did the anti-cheat implemented by Nintendo work? Well, the answer would be no, because we managed to get a score of 99,999. But then maybe it worked, because later on, I think a few hours or one day later, we got banned. So they might have something that we can classify as a passive anti-cheat method, where it's either automated or manual inspection, where someone looks at the scores and the gameplay of different things, and if it's out of normal bounds, like our score, then it should get banned. From here on, my colleague Greg will try to explain more about the engine that we created for this exploit.
Thanks, Antonio. So for our dev flow, basically we created an API that we could attach to using Frida to the running binary, and with that basically call whatever methods we want very easily and efficiently. The way this API worked, the way that we developed it, was we took the dump of the metadata, that's dump.cs, and created a custom parser that just passed it into a JSON file, fed that into a Ginger template that created some JavaScript, and put that together with cheats.js, which is, it's in the name. With that, we basically have a way to create custom cheats on the fly and run them in Frida. What does a custom cheat look like? So on the right, you can see the JSON metadata for one of the functions. In this case, it's the add action score function for the race score recorder method. So that controls your score, and it takes an integer value that tells it how much to add to the score. And we just replaced it with 1,337 at the top, leet. That's in our cheat at the top, and over time, over the course of the gameplay, you end up with a max score of 99,999, which shouldn't be anywhere near possible. You should get in the 10,000 to 15,000 range of points. So that's probably why our account got banned. That's pretty easy to detect if someone gets an insane score like that. What Frida does is it can attach to a function on enter and on leave. And in this case, we just change the arguments going into the function every time the function ran. I don't recommend doing this. I don't recommend creating your own custom API like this. It was after our project that I discovered that someone had made a much better way of doing this that's a lot faster and more efficient. And if you want to do something like this, mess around with Android games, I recommend that you use this GitHub repo. It's really, really cool. I recommend trying it out. But anyways, we ran into another issue, which is that there's 99,600 different functions, approximately, to look at. And sifting through those manually in a short amount of time is quite difficult. So we need an intelligent way to find which functions did what. And we tried hooking all the functions just to see what would happen. And of course, the game crashed because that's a lot to handle. So I created another custom tool called a timeliner. What it does is it will automatically record your screen, and at the same time will hook onto certain a subset of functions that you can define using a regular expression. And it allows you to very easily look up frame by frame which function is running when, more or less, and with a little bit of leeway of about 10 microseconds, or 100 microseconds, something like that. Yeah, that way you can very easily figure out which functions are running when, and that allows you to figure out which functions you want to hook to and which ones you want to hack and patch. I should note that for ethical reasons, we were looking primarily at the single-player mode of Mario Kart. We didn't want to ruin anyone else's game. Having said that, another way that you could hack, if you were going to hack multiplayer, is to just reverse the packets being sent on the wire and not actually touch the binary itself. So we didn't spend too much time on this because we were running out of time at this point in our project. But I think it's worth noting, we're looking at the UDP packets that are sent during multiplayer to see if we could reverse any of that just off the bat, and primarily to see whether or not these were encrypted. What we found is that some of them aren't encrypted. So byte 12 of the UDP packets, for example, give this sort of sawtooth pattern when you plot it on a graph. So it goes up and drops. Anyone who does networking here might recognize this as some sort of maybe a congestion algorithm to deal with congestion on the network. Byte 13 shows another similar, or another pattern. So these are clearly not encrypted, which would make sense. And we found that a few of the bytes at the head of the file and a few at the tail of each packet, of each payload, showed patterns, which indicates that they were probably not encrypted. The rest of the packet was a bit inconclusive, and we didn't have time to dig further, unfortunately. But we can leave that up to you guys if you want to reverse some UDP packets. But we had another account, and it wasn't banned, so we thought we'd give another shot at single-player mode and see if we could come up with any cheats that were harder to detect. And our philosophy behind this was that if we tried to reuse the code of the game itself as much as possible, then the behavior would probably be similar to how the game would react, and therefore it might be harder to detect, especially if they're using a passive detection technique where they just look at the results of each game. So no more 99,999 points. You have to keep it in a reasonable range. And to do that, we tried a whole bunch of things, and we came up with what we called the silver bullet exploit. The way this works essentially is during gameplay, you will, at certain intervals in the map, get a random item. This item is a little lottery, a weighted lottery. So sometimes you'll get a really, really good item, like Bullet Bill. It turns you into a bullet, you're on autopilot, you're invincible, and you're going at twice the speed. The problem is that you're only doing that for about 3 seconds. So it's nice, but it's a bit short. So what would happen if we rigged the lottery and also made it so that we just stay in that state forever? Yeah, you're basically guaranteed a win. And it's also harder to detect because you won't get the maximum points, but you will come first in every single game, guaranteed. And we actually have a demo of that, if we could pull up the video. So here you can see a normal single-player game. I'm playing against a bunch of NPCs. And lottery starts. There's a little bit of a lag as we hook a bunch of functions. And just like that, we've rigged the game. And yeah, you have no ability to act against us. And just in case anyone's curious, this would also work in multiplayer. You can create games with just 2 people. So we used it with 2 devices that we controlled. And on the second player's screen, all you see is first player going around the map really, really fast. Yeah, so in this situation, I think all the NPCs have just passed their first round now, and we're about halfway through the second round. So yeah, there's no way you can compete. You're guaranteed to win. Switching back to the slides.
Do you see it in bullet form? The player sees in bullet form?
The second player, the legitimate player, will not see you in bullet form now. Yeah, fun. So interestingly enough, Nintendo, a couple days after we got banned, Nintendo released a new patent for an anti-cheat method. And interestingly, it uses code reuse. So they didn't give too many details, but it sounds a little bit like ROP chaining, if, for those of you that might know about that. But basically reusing code from within the game to check to see if the game has been modified. It's really, really interesting, and I think it will pose an interesting challenge for game modification. So yeah, curious to see where that goes. Ethical considerations. I told you that we only wanted to do things in single-player mode. What we didn't know was that single-player mode was ranked. And we may have ruined some poor kid's day. Or week, seeing as these are weekly ranks. But yeah, a lesson in double-checking your scope. But yeah, this was an interesting look into trusting the client, trusting a game client, and looking at how anti-cheat and anti-tamper methods are implemented in that. If you want to go ahead and mess around with your own Unity games, I recommend checking these links out. It will give you a really good head start, especially that Frida IL to CPP bridge. That's an amazing API tool that I think is very, very useful. Thank you very much, and I hope you enjoyed.
Thank you guys for sharing this with us. Let's see if we have questions. Yeah, we have questions in the audience. Let's start with the first question.
Hello, and
Hi.
Thank you for the presentation. I have a quick question. Did the anti-cheat patent after 19th of May, right? Did it get implemented into the recent Nintendo games on Google Play?
No, not that we've heard of yet. They announced the patent, and that's as far as we know about the anti-cheat. We don't even know if it's been developed, just that it's...
Is it safe to assume, or you probably didn't get the chance or the time to investigate that, if the same techniques work on the same Nintendo apps, games that are published right now?
I haven't checked Mario Kart, but I can attest that I've checked out other Nintendo games recently, and the same techniques do work. So, yeah.
Thank you.
Sure.
Nice presentation.
Okay, we have another question over here. Just defaulted to your question.
Hey guys, just wanted to know, I actually have two questions, can I be very quick? Have you used something like Cheat Engine? Because it's like very useful in desktop games. So have you used something like that here?
Yeah, I grew up messing around with Cheat Engine. In this scenario, we were hacking an Android app, so it was easier to use something like Frida. If it was a Windows program, I probably would have messed around with Cheat Engine as well. Nice access to memory.
So nothing similar to Cheat Engine for Android, that's what I was asking. Didn't use something similar, just Frida?
If there is something similar.
Okay.
I don't know. I don't know if there is a memory, like a memory editor like that.
Or if you've used it here, but you say you've only used Frida for that.
Frida, yeah. But if you use Frida right, you can give it just as much power, if not more, than Cheat Engine.
And the second one, I don't know if the presentation is over yet, but it was something about patching. You didn't tell us about how you patched the application. Like,
Right.
did you use, after hooking, right? In order to create an APK, you need to patch it, like to decompile it to Smalley code, and then edit the Smalley code, recompile it to an APK, right?
So the slides that you're referring to, we were talking about how security and game hacking have a lot in common, right? And in our scenario, we didn't focus too much on patching, more on hooking, which is kind of, I suppose, on-the-fly sort of patching, right? Yeah, we just hooked the functions. There was some patching involved, but that was more with other tools. Things like the IL to CPP dumper that we used patches the binary as it loads into memory, and yeah. There is certificate pinning, but not for the UDP packets. For some of the API calls that were web requests, that's certificate pinning, yeah. Other questions?
Yes, and we have another question here.
Thank you. What do you think about games going for more aggressive anti-cheats, such as those at the kernel level? Are they really that harder to bypass, and are they safe for the user?
I'm definitely not an expert in attacking kernel level anti-cheat, but I do think it is a lot harder. I would imagine. Yeah, I'm not a huge fan of that. Obviously, I don't like people cheating in games either, but I don't like anything running in my kernel that is just there. Yeah. That's a good question.
Okay, we have another question over here, another question over there, please.
Hello, nice presentation.
Thank you.
Can we read somewhere more details on your research?
We have a paper, if you want to read a technical paper.
Yep.
Yeah, we can definitely give you access to that. We have our contacts are in the slides.
Okay.
If you just
I'll hit
email
you
one
up.
of us, we'll be happy to give you access.
Thank you.
Sure.
So, next question. First the hat.
Hello.
Hi.
Okay.
Yes,
Hello.
Man with fedora. Yes.
Quick question. So, first of all, the second account that you managed to use the bullet hack, did it get banned in the end, or did it manage to stay unbanned?
No, we remained #1 for a week, and as far as I know, that account is still active. Well, it's not active; we're not using it, but it hasn't been banned. Is what I'm saying.
And one more quick question. From your research, did you hear of any anti-cheat method that protects from using Frida for trying to hack the application?
The author of Frida himself, Ole, has mentioned that he stumbled upon anti-Frida techniques being used in applications, but according to him, it's futile to try and do something like that because Frida sits on top of the application, so you can always patch the functions that are looking for Frida. Yeah.
Okay, let's see if we have any other questions. Yes, we do have another question.
Regarding time, I'm only asking for the neighbor of my brother's friend. Is Timeliner on GitHub?
It's not.
Will it be?
If I can work out some kinks and make it worth your while to actually use.
Yeah, even with contributions from from my neighbor's brother's friend.
What I can recommend is that other project that I mentioned, the Frida to -ILCP bridge, has a tracing function integrated into it, which does the same thing as Timeliner, just in your terminal. You could easily write a little Jupyter notebook that integrates with that. Sure.
Awesome presentation, guys. Thank you so much. Let's have a round of applause.
Thank you, everyone.